Hello there. In this video we're going to go from a sinusoidal graph, or information about a sinusoidal graph, to the rule that makes it. So we have some bits of information here about where a minimum and the nearest maximum is going to be. So let's plot that in our graph. Oh, looks like I got a little bit carried away with that one. Okay, so I got a bunch of tick marks, labeled them from 5 to 5, 10, 15, and then we'll get the minimum. Y-axis, I mean. Okay, and put the points down. Okay, so from here, we're going to consult our maps. And we might change the order that we do this exactly, but we got to remember find midline, amplitude, period, shift. When we have all of that information, we can write our rule. So there's a minimum up to a maximum. That's a total distance of 6. So halfway in between that, we're going to have our 3, and that's going to be where the midline has to be. We can sketch that in. So there's that, and our distance to the maximum and minimum from that midline, remember, is 3. So that's actually what our amplitude is going to be. So midline's at 6, amplitude is going to be 3. And just as a reminder, that 3, that it doesn't mean that 3 is the coefficient in front of everything. It means that the absolute value of 3 is the coefficient in front of everything. Maybe it's a positive 3, maybe it's a negative 3. We'll find out. It also kind of depends on where you have the graph, quote-unquote, start. All right, so I got those. Now I'm interested in what the period of this thing is. So we can kind of imagine that we have a minimum, come up to a maximum, come back down, come back up, come back down, weaving around this line. Where is it going to hit the next, the minimum again? So the distance from the minimum to the maximum, horizontally, is 3. Actually miscounted and got 4 the previous time. Now we're going from 1 to 2, so 1, 2, 3. That takes us from 1 to 4. So that means that after another 3, so 1, 2, 3, we're going to be back down here again, so at 7, negative 1. So that's a total distance of 6. Then after another 6, that will take us all the way up there. We're going to be back down again at the minimum at 13, negative 1. And 3 after that 7 is where we're going to hit the maximum again. So that's going to be at 10, 5. So we can see the distance in here. That's 6, that's 6, that's 6. So our period is 6. And we know the formula, this is an important formula, that the period is equal to 2 pi over b. B is part of the formula. So we then know that 6 is equal to 2 pi over b. So that 6b is equal to 2 pi, and then we can divide both of those by 6. So b is actually going to be 1/3 pi, and that will be used in our formula in a bit. So that the period, the 6 actually is not a number that goes as itself in our eventual rule, but it helps us find the scalar b. That's going to be a coefficient on the inside of the sine or cosine function. All right, so another thing that we need in the graph, between the minimum and maximum, is halfway in between those is where we're actually going to hit the midline. So after 1.5, we're going to have a point here on the midline. 1.5, we're going to have a point here on the midline, here on the midline, here on the midline, and it just keeps going. 1.5 backwards, we're actually going to hit the midline again. So if we're sketching it, this is where we can begin to draw that curve. It's got to come down, be smooth, up, curve down. It doesn't quite look like a maximum. There we go. Come back down, come back up. So very gentle curves there. It looks like my maximum got a little bit shifted over that one. We could try to smooth that out a little bit. Oh no, that looks bad. I'll erase that. Okay. Now what? now we want to look at where we're starting, because if you look at the 0 on this thing, kind of looks like 0, 0. I actually don't think it's going to be 0, 0. It's probably up or down just a little bit. The graph could be misleading there. Music's coming. Okay, start. Let's start this one. We need to start it as a cosine function. So that means that we need to start at a maximum or minimum. Let's do it at the closest one. So let's view this as the start. So what that is going to mean for the final equation here, we can begin to write it out, is that we're going to have y equals, we have this amplitude of 3, don't know if it's positive or negative yet, cosine of that b value scalar, that's going to be pi over 3 times x minus 1, end all that, midline adjustment, but then we're actually starting down here at a minimum, and if I put in a 1 in here, 1 minus 1 is 0, times that stuff is still 0, cosine of 0 is 1, 3 times 1 is 3, plus 2, that actually would start me up at 5, but we're starting down below. So because this one's starting at a negative, I need that in front to be a negative. And that's going to be our rule. Now, this whole start thing, we actually could have started elsewhere too. Like if I had started up here as a start, I'll just keep going. Y equals the amplitude 3, starting at a max or minimum, still cosine. The period didn't change. The starting point shifted, x minus 4 now, plus 2. And then when I stick in a 4, 4 minus 4 is 0, still 0, cosine of 0 is 1, 3 times 1 is 3, plus 2, it does get me up at 5. So this one is going to be positive. Now, if we had wanted a sine wave, so let's change this to sine. Sine starts on the midline. So if we view this as the start, then our equation becomes amplitude still 3, sine of, period didn't change, so still pi over 3, x minus, where is this one located? That's after 1.5, that's 2.5, I think, 2.5. Midline's still the same, and it's going up there, so this one would actually be positive. So, there's all kinds of different rules that you could make for these. We're going to try to specify, do we want a sine wave, do we want a cosine wave, and you should always start it probably closest to the axis that you can get in a sensible fashion. Like, don't start way over here. That would be silly. Thank you for watching. Character and Scholarship for Life.